Hello, my friends.
What's up, people?
Yep, Mr. Knowles over there. I'm right here. You're right there. We're going to do 6-2. That's on pages 304, 305. All right, we are going to go over our second transformation. Pop quiz, what's the first transformation we know?
I know.
What is it, Mr. Knowles?
Translation.
That's right, translations. All right, so
There's
there's
a slide.
AKA slide. So we've done translations. We're about to do number 2. Right, I don't know what it's called. We got to watch the video. You guys got to be good listeners. Figure out what it's called. Okay.
This is going to be good.
Yep. It's going to be great, Mr. Knoll. Okay.
Even better than good.
Anyway, 304, 305. Let's go. Right to
How
the
does a
line action.
reflection affect the properties of a two-dimensional figure? Think about this question during
There's
the
our
lesson.
new one.
The client wants the architect to flip the placement of the grill,
We've seen this
putting it
before.
on the other side of the patio.
What?
Where does the client want the grill to be placed? Can a picture or an object be used to represent the
Sure.
problem situation?
Absolutely.
Okay, so they've given us 2 words that mean the same thing. So they said in the opening question, hey, reflection. So there it is. There's our second motion. Now, I don't see the word reflection in here. They used a 4-letter word. Starts with an F. That's right, flip. There it is.
Flip.
Right? That's what we also call Mr. Philippi. So if you call him Mr. Flip, he'll answer to that too, okay? So anyway, flip also means reflection. Here's the grill. We want to flip it across the patio to the other side.
Flip
Right?
it.
We can all imagine what that would look like. Where do we think the grill is going to be? We're going to flip it from here. I'm thinking it's got to be over here somewhere, okay? Let's keep watching and see what happens. It's good stuff.
The architect flips the placement of the grill over the vertical line segment,
Yep.
dividing the patio. A reflection, or flip, is a transformation that flips a figure over a line of reflection. Reflected figures are the same distance from the line of reflection, but on opposite sides.
Huh.
Where will the grill be placed after it is reflected?
Okay.
Select your answer.
So they gave us a lot there. So they said reflections, also known as flips, and they flip or reflect over a line of reflection. That is this red dashed line here, right? And they also told us another important thing. And they said, hey, this grill is going to be the same distance away when it flips over that line of reflection. So in other words, like let's say the grill's 20 feet away from this line. Well, when it flips over here, it's going to be 20 feet away again, okay? That'll be key, especially when we see stuff on our coordinate grid, right? And we're going to have to do lines of reflection then. So anyway, you guys want me to pick one of the wrong answers?
Yes.
Ooh, that was good. How about this one? Oh, should we pick the right one? Yeah, of course we know it's going to reflect over here. There it is. It's like a weird cowbell.
Remember where the original location of the grill is. Watch as the location of the grill is reflected. Here's the new location of the grill.
Yep.
The original location and the new location of the grill are the same distance from the line of
That's what
reflection.
we just talked about.
The reflection of the grill is the same distance from the center, but on the opposite side of the patio. The grill still has the same shape and size. However, the orientation, or direction the grill faces, has changed.
So, guys, there's the most important thing. If you think about, right, we've all seen a grill before, right, here. Like, I'm going to pretend I'm standing over here, right? So here I am, I'm standing, I open up the grill this way, right, and I'm flipping my burgers. Now, when the grill flips or reflects over here, right, I'm not standing on this side of it. Now I'm standing back on this side of it, and now I'm opening it up here, flipping my burgers, doing all that fun stuff, okay? So the orientation changed. So you have to do that trick of, hey, if I go around the figure, right, name all your vertices. If the order changes, that's how we know the orientation changed, okay? I think that should just about do it for this example, but we'll see if they have anything else good to say.
Now, you know that a reflection affects the orientation of a figure,
Yes, it does.
but it doesn't affect its size or
Nope.
shape.
Nope. So when we think about our properties, key concepts question number 1. 2 things change, but 2 things stay the same with a reflection, right? And they just said them right there. The shape and the size don't change. Those are the same. What does change, right? Orientation, position.
Huh.
Yep, it's good stuff, Mr. Knoll. All right, here we go. While updating the design, the architect accidentally clicked, oh no, on the chair, and reflected it across the center line. Again, the center line is there in red.
Here's the chair.
Yeah, the chair's right there. Draw the new location of the chair on the plan. Okay, so it's our turn to reflect something. Again, I don't know how far this is, guys, but whatever distance this is, when this chair reflects over, right, this distance here is going to be the same distance on the other side, right? And here's our chair. It's going to be right here, okay? That side will be filled in or something. I don't really know, okay? But it's going to be right about here. Hopefully your chair looks a little bit better than mine, okay? How do the pre-image and the image compare? Well, is the chair the same shape? Yes, it is. Is the chair the same size? Also, it is. Is it in the same spot or the same location? Nope.
No.
Does the chair have the same orientation?
Uh-uh.
No, that's changed too, okay? And guys, that's hard to see with squares. Easier to see sometimes with objects that face one direction, like a triangle or something like that. So we really have to double check to make sure we're doing this right when we get squares, okay? Okay, make that go away. And here we go, example number 2. Let's see what we get here. More good stuff. Hopefully we get a graph. Yes.
I love graphs.
Polygon ABCDE has vertices A, -5, 2,
Yep.
B, -5, 4, C,
This guy's really excited.
-4, 5, D, -3, 5, and E, -3, 2. Graph and label the vertices of A, B, C, D, E and its image A', B', C', D', E', after a reflection across the x-axis.
There we
Hey,
go.
can I ask the lemon head question of the day? What type of shape is this if it has 5 vertices?
Quadrilateral.
No.
Octagon.
No. That would have 8.
Hexagon.
No, that would have 6.
I feel like we should have a building named after this.
There is. One of the largest buildings in the world.
A lot of concrete
Yes.
in the Pentagon. That's right.
In the Pentagon.
Okay. Although I don't know if this is a pentagon shaped or not. Anyway,
Well, it still doesn't matter. It's got 5 sides. It's a pentagon.
pentagon. Okay. So here we go. So step 1, guys. They took those 5 vertices. Bam. They graphed them on our coordinate plane. Right now, here we go. We are going to reflect across the x-axis. That's my line of reflection.
What does
Okay.
reflect mean? What word else could we use?
That is the line that we flip it over,
Flip it.
Mr. Knoll.
Flip.
You big dummy. Okay. Here we go. Bam. Here, you guys want me to draw in? I will draw in. So here is the x-axis, my friends. Right? There is our line of reflection. So we are going to take the polygon, bloop, and it's going to reflect over. Easy to see how the orientation is going to get changed here.
Yep.
Okay?
Yep.
All right, so they're going to do that. All right, there we go. All right. Again, is the shape the same? Yes. Is the size the same? You betcha. Is the location? No, that's changed. How about the orientation? Again, here's that test that we do. If I start here at A and I just work my way around clockwise, right? I go A, B, C, D, E. Alphabetical order, that's good. If I start at A and I keep going in that same clockwise fashion, what happens here? I go A, E, D, C, B, okay? So when I don't say the same letters in the same order, that means the orientation changed, right? And we can kind of see it because this little cutoff side here, BC, right, which is in the top left, all of a sudden down here is now in like the bottom left, okay?
That's right.
So anyway, that's how this works. Again, if we're going to reflect A to A prime, right, how did they do that? They just counted. That's all they did. Mr. Knoll, can you zoom in here for me?
You bet.
So if we're going to reflect over an axis, I'll get rid of that line, don't worry. All we have to do, gang, is count. Literally, that's it. It's just like when we translated, and we would go up 2 and over 4. We just count. So I take point A, and I go, okay, yep. Again, remember, here's my line of reflection right here. Right? All I have to do is count. Hey, 1, 2. So it's 2 units away from the line of reflection. That means when it reflects, it will still be 2 units away. 1, 2. Okay, there you go. Label it A prime. Do the same thing for E. It's 1, 2 away from the line of reflection. 1, 2 away. Okay?
Huh.
E prime. We just repeat that for B, C, and D. That's how they reflected them here. Okay? As we do more of these, you will become more comfortable with them. I know it.
Do you think we'll do some extra practice at some time?
Possibly. Possibly.
I sure hope so.
Okay. All right, Mr. Knowles is going to unzoom me,
Oh,
and then we're going to move on to example number 3, believe it or not, folks. Oh, wait, hold on. We got to try it here, don't we?
We do have a try it.
Yes. And I don't have a graph for this one. Thanks a lot, people. Okay. Quadrilateral, blah, 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 blah. Reflected across the y-axis. What are the coordinates of point N? Okay. I can do this one without a graph. Well, I'll make a graph, just like I know all of you will. It only is asking me about point N, so that's really the only point I'm going to worry about. So N is at 3, 2. Okay. 3, 2. So 1, 2, 3, 1, 2. All right. So here's point N, and this is at 3, 2. Okay. Now it said we're going to reflect across the y-axis. So here is my y-axis. Okay. I'm gonna give myself 1, 2, 3. I think that's about all I'll need. Okay. So if I reflect this point, I literally am just counting how many spaces away it is from my line of reflection, and then it's going to reflect on the other side that same number of spaces. So guys, I'm 1, 2, I'm 3 away from the line of reflection. That means I got to reflect 3 across on the other side. 1, 2, 3. Here is N prime. Bam. What's that ordered pair? That's what it wants to know. Well, -1, -2. This is at -3. Interesting. Did its height change? Like, did it go up or down? No, this number stayed the same. It's not by coincidence, guys. That always happens, okay? So what are the coordinates? My coordinates, guys, are right there. -3, 2. If we were reflecting over the x-axis, guys, the x-coordinate would have stayed the same, and the y-coordinate would have changed.
I bet you we'll do more practice with that soon.
I can only hope, because, you know what? I love some reflections. Okay, example 3.
Just
Now,
because you love looking at a reflection of yourself.
that's right. Who wouldn't? Nope. Talk to me.
What is a rule that describes the reflection that maps parallelogram ABCD onto parallelogram A prime, B prime, C prime, D prime?
Okay. So, guys, here's what we have to do, right? So, we will reflect points, right, across a line of reflection, right? Just like we kind of did on that last example. And then other times we're going to have to find the line of reflection. Sounds complicated. I promise you it's not. All we have to do is find, hey, what is the middle point between these 2 points right here, okay? And it doesn't matter which pair you choose, as long as they're the same vertex, like A and A prime, or B and B prime, or C and C prime, okay? So I'll choose A, since it's all the way up here. So here's A and A prime. I literally just want to find what is the middle point between those 2, right? So it's like, okay, here goes 1, here's 1. Here's 2, there's 2. 3. So right here, this is the middle. Okay? That's how they're finding. The book doesn't do a great job of explaining this. That's why I took some time here, guys. That's how they're finding this right here, which is our line of reflection. Now we just have to name it. Does this line have a special name? Well, of course it does, guys. That's our y-axis, in case you didn't know that. Okay? They're going to give us some trickier lines here in just a bit, but I know you guys are good. We'll be able to find that, okay? So yes, there's our line of reflection. It's the y-axis. Okay? And then they just go right to being a jerk, and they give us a horrible line of reflection.
This is a terrible line of reflection.
Okay? They said x equals -2. All right, here's how I'm going to tell you to find the line of reflection x equals negative. Sometimes it's going to say x equals a number. Sometimes it might say y equals a number. If you just remember what I tell you here, you'll always get this right. So I want you to go to the x-axis. I want you to put a dot on -2. Go do that. X-axis, got it. Dot on -2. Bam. Okay? Now I want you to draw a straight line through that dot. There it is. Okay? So there's my line of reflection that I want to reflect across. I have 1, 2, 3, 4, 5 points. So I have to reflect all 5 points across this line. Remember, they're going to be the same distance away. So, Mr. Noel, zoom in for me real quick.
You betcha.
There we go. Perfect. I'll redo my line of reflection here for the people. Okay, so x equals -2. Bam. Can you guys see that more better now? Yeah, that's really good. Okay, so I'll just start here. So I'm going to start at C. If we're going to reflect C, it's 1 unit away from the line of reflection, so it reflects to the opposite side, and it's still 1 unit away. C prime. Okay, I'll just go to B. It's also 1 unit away. It will reflect 1 unit away over here. B prime. A, 1, 2 away. 1, 2 away on the other side. A prime. See how easy this is? E, 1, 2, 3 away from the line of reflection. 1, 2, 3. E prime. Last one's D. Also 1, 2, 3 away. 1, 2, 3 away. Okay? Make sure you connect the lines in the same order. Right? You can't just be drawing your lines all willy-nilly. Okay? There we go. So, what was the same? Shape, size. What changed? Location, orientation. If you don't believe me, guys, look. A, B, C, D, E. Start back here. A, E, D, C, B. So different orientation. That's how we check it. Important to do that now because our orientation is going to change on some of our transformations. Okay. So guys, with it, that is reflections. I hope you enjoyed it. Again, this was transformation number 2 that we will now begin to learn and work on, okay? If you get rid of this video, come to the next one. I'll be doing the key concepts on that page. See you then.